Hi, class. This is your physics lesson for Thursday, September 17th. As I mentioned in our live class yesterday, on Tuesday, I had given you some information on how to rearrange formulas, how to solve formulas, if you will, for one variable in that formula. And the one we used was S, speed, is equal to d over t. Speed equals distance over time. And I showed you how, I gave you some rules and showed you how to rearrange that equation so we could solve it for d equals and for t equals. That was a rather simple equation. Right? It was just three variables, and there was only one operation inside that equation. For this lesson, I want to add a few more variables, and I want to add a few more operations, and to show you that it really isn't that much more complicated. We can follow the same rules, and I'm going to go through those rules with you on following another common equation we're going to be using in physics this year. And this equation that we're going to talk about today is V equals V0 minus AT. So V for velocity, V0 for your initial velocity, A for your acceleration, and T for time. So we're going to go through the same process we did before. We want to rearrange this equation so we can solve it for V0. Again, what does that mean? That means we want V0 as alone, and it'll be on the left side of our equation. Right? The one I have here is solved for V. We're going to rearrange it so it's solved for V0. So the first question I want you to ask is V0 already alone? Well, if we look at our equation down here, no, V0 is not alone. There's an AT already added to it. So here our answer is going to be for this question, right? For this question, we're going to say no, it's not alone. What is with it is the AT. We've got an AT term, acceleration times time term, added to our V0. So our next question, what's the mathematical operation that connects AT, that variable AT, that's not at there, that's the variable A times T, to V0? And again, if we look at our formula here, V equals V0 plus AT, we see that AT is being added to V0. Okay, so we're just looking at V0 today for the beginning of this lecture, and how is it put into the formula? And here we have that their AT is being added to our V0. So our next question, what is the opposite of adding AT to V0? Adding the variables AT to 0. And we're going to see that, how do we get rid of that AT? That's really what we're asking. How do we get rid of that AT? And what we're going to do is we're going to subtract the AT from the V0. Right? Adding and subtracting are the opposites. Right? So if we're adding something, the way to get rid of that is to subtract. Next question. Now, if we've done the subtracted of AT from the right side of our equation, what do we got to do to the left? Well, hopefully you remember from our rules earlier, whatever we do to the right, we've got to do to the left side. Whatever you do to one side of an equation, you got to do the other. So if we're subtracting AT from the right, we better subtract AT from the left. And now let's answer this one. And this is where it gets a little different from what we've done before. Is there more than one mathematical operation acting on V0? And here the answer is yes. Right? Here the answer is yes. Well, I'm sorry, here the answer is no. Take it back. Our answer is no. Right? V0 is here by itself. We just have one operation, and that's the addition of the AT. So now we can solve it. We've looked at our equation. We've thought about our rules and how they apply. Let's actually step through it in a little bit more detail. Again, if you remember, the very first thing we want to do, if we're going to undo a mathematical operation, we must do the opposite. And we identified earlier that the operation we were doing was we were adding an AT. So to undo it, we need to subtract an AT. Rule number 2 then said, well, whatever you do to one side, you better do to the other. So we have to subtract an AT from our other side as well. All right. This leaves us with our V minus AT equals V0, right? Because if we're subtracting them, what's happening here, these guys are going to cancel each other out. That's the whole reason we're doing opposite functions, opposite operations, so we can get rid of that AT. So now we have v minus at equals v0, and all we did is use rule 4. We flipped it around. We want to have our variable by itself on the left-hand side of our equation. So you see, this one isn't all that much harder. Just because there was an addition here instead of a division, like we had s equals d over t, we just still do the opposite operation, and we flip it around left and right, so that we have our answer here. So this one's not too bad. Now, this one's not too bad if you're solving for v0. What happens if you're solving for a? Look at our equation here. What happens if we're solving this equation for a? Now, again, when I say solving it, I might use the term rearranging, but when I say solving it, we want to have the a all by itself on the left-hand side of our equation. So we want to change this so it has a equals what's going to be on that right side. So again, looking at it, is a already alone? Well, no, a is not alone here, right? A is not alone here. What's with it? Well, if we look at our equation here, not only is there a t, but there's also a v0 here, right? So there are two variables over here with our a. So our answer here is going to be option C. Both v0 and t are with our a. Now, what mathematical operation connects the v0 to the at? Okay, well, let's look at that. How are we connecting these two here? There's an addition, right? Our v0 is being added to the at. And what's the opposite of adding? The opposite of adding is going to be subtracting. So we're going to subtract our v0 from our at. We want to get rid of this v0 plus, so we're going to subtract a v0 to get rid of it, to undo it. But we're still not done. We're still not done because there's another term here, right? We still got to deal with this t and the a over here. The a is not by itself. So how are the a and the t connected? Well, we can look at our equation. What do we see? A is, whoop, wrong one there. A is multiplied by t. So hopefully you know what the next question I'm going to ask you is, how do we undo that multiplying by t? The opposite of multiplying is dividing. So if we've instead of multiplying a by t, we're going to divide the t by the we're going to divide a by the t. Okay. Now, again, if we're going to divide by t on the right side, what do we got to do to the left? Our rule tells us we have to do the same thing on the left. We divide by t on the right. We better divide by t on the left. Okay. So we've gone through and we've looked at this in a little bit of detail. Let's put all those steps together. Oh, one more thing to ask here, right? Is there more than one mathematical operation acting on a? Well, here the answer is yes. Right? We're multiplying by t, but we're also adding that v0. So there's two operations going here. Two operations going on here. Now here's where it gets a little tricky. Which operation should we undo first? Well, if you look at your notes, I forgot to put it here in the slide. If we're going to undo things, we're going to do them in the opposite of the order of our order of operations. Now, maybe you remember this from your math class. There's a nice little acronym for remembering that. PEMDAS, P-E-M-D-A-S. P stands for parentheses, E stands for exponent, M stands for multiplication, D stands for division, A stands for addition, and S stands for subtraction, PEMDAS. So that tells you the order in which we need to solve our mathematical equations. So if we look at that, when we're going to go backwards, right? If we're going forwards, PEMDAS, you're going to see that the division, D, happens before the subtraction, S. But if we're going to go backwards, flip that around, the first thing we need to do is subtract the V0 from our AT term. Subtract the V0 from our AT term. Okay, remember the opposite of our order of operations. Well, there's only one other thing we can do, right? It says which operation we're going to do second. There's only two operations. So the next thing we got to do is divide the A by T. So let's put this all together, put it all on one page here, because we've analyzed the little parts. Let's make sure we can see some of this a little bit better. So if we're going to solve for A, again, here are our rules. To undo the mathematical operation, you must do the opposite. Right? So what are the mathematical operations we're doing here? We are adding V0, and we are multiplying by t. Those are the two mathematical operations we have here. Now, Rule 2 tells us that whatever we do to one side, we have to do to the other. Whatever we do to one side, we have to do the other. So make sure we're doing the same thing on the right and the left. And it's really Rule 3 where it kind of gets where we add a little bit of the complexity here for this particular equation. And says that there's more than one operation going on. We must undo them in the opposite order. In the opposite order. Well, we just talked about that. If we're going to undo them in the opposite order, that means we need to do the subtraction first and then the division. All right. So how do we undo our addition here? All right, we're going to subtract V0. Rule 2 tells us to do it to both sides. Now that we've subtracted our V0, Rule 3 tells us we got to do the other operation. What's our other operation? What's dividing by t on both sides here. All right. That leaves us this equation, V minus V0 over t equals A. And then Rule 4 says we just have to switch the equations, right? We're going to switch the left. Whoop, why didn't that work the way I wanted? We're just going to switch the left and the right, right? We just switch the sides for the terms. So this one was a little more complicated only because we had two operations going on here with regards to the A. It was being multiplied by t, and it had a V0 added into it. So the part I want you to remember here is just how do we figure out what the order is? We have to remember what the order for PEMDAS is, P-E-M-D-A-S, parentheses, exponents, multiplication, division, addition, subtraction. And we got to do it backwards. We got to flip that order around. So in that case, that means we need to do our subtract. We need to get rid of our V0, get rid of that addition first. We did that by subtracting the V. And then we got to get rid of the t. And we did that by dividing by t. Okay. The last part here then is, what if we solve it for t? That's the other variable in our equation. And how do we do that? Well, what I want you to look at here, look at this a and the t in our equation. Look at the a and the t in our equation. They're both in the same functional place. And by that I mean, what happens if we flip it around? What if I wrote this equation instead of v minus v0? I could easily write this equation as I could have easily rewritten this equation and put the t first and then the a. So it's really not right, because multiplication, you can flip the order around. So they're really doing the same thing. I can just switch those two variables and nothing really changed in the equation. Because of that, we can look at what we just did in solving our equation above for a, and all we got to do is swap the t and the a. So we look at our equation above. What did we do here? Here's what our function looks like for the when we solved it for the a. Right? Because we can see from our original equation the a and the t are functioning in the same way. They're in the same functional place. All we got to do is swap the t and the a. All we got to do is swap the t and the a in the equation we got for a, and we're going to have the equation for for t. Now, you could go through the same whole set of rules again. That will always work. What I'm trying to show you here is take advantage of something I'm going to call symmetry. And it's a big thing in physics, taking advantage of things in symmetry. And that's where can you see that the variable performs the same way, right, or in a similar way. So here a and t are symmetric. Whatever happens to a, the same kind of thing's happening to t, right? A is multiplied by t is multiplied by a. V0 is added to that product, both cases. Right? So we have that symmetry involved with these two variables. Use that concept, and it will help you solve a lot of problems much, much faster. All right. Well, hopefully that works. Hopefully that helps you as we're doing some of our mathematical manipulations. Again, we will see this equation in the future, v equals v0 minus at. I wanted to give you just kind of a foreshadowing of that and kind of go over the math real quick with you. And if you're uncomfortable with some of these math, working with some of these variables, moving some things around, I'm going to put a couple of practice problems out there in today's folder. And please take a look at that, and I'll provide the answers to those as well. But the whole idea here is I want you to get comfortable with the math. Let's not focus on the physics for a moment. Let's focus on the math. Make sure that we're comfortable with it so that when it does come time to focus on the physics, we are comfortable with the math and it doesn't get in the way. It doesn't distract us from doing the physics at hand. All right. If you have any questions on this, guys, please send me an email. We can trade emails back and forth to answer it if we need to. We can also set up a quick Google Meet or a quick Schoology conference for the two of us to talk together in real time. All right. Thanks, guys. Thanks for listening to this lecture. Hope this helps clear things up a little bit, and we'll talk to you next week. Take care. Bye-bye.